Chapter 3, Optimization Word Problems practice test for you today. I'm sorry I've been off for a while with a bad cold here, but I'll do my best to try to get through these so you'll have something to practice with. So here is the test that I gave my grade 12 class several years back. So I will put a link to it in the description of the video, and you can either just freeze frame it and try this word problem. I'm going to do the first two. I'll do two on each of the videos and get you all prepared for your test. So the first question, the starting point of a race is on an island 4 kilometers offshore in a straight river. The finish point is on the river bank 6 kilometers downstream. Bill can swim at 6 kilometers an hour and cycle at 12 kilometers an hour. Assuming Bill can have his bicycle waiting anywhere on the bank and neglecting the influence of the current, that was in the vectors unit, what point on the shore should he aim to get from the starting point to the finish as quickly as possible? So I'm telling you right now that there will be one of these on your unit test. Without a word of a lie, this is probably the most common optimization problem. It could be a distance, speed, time one, or it could be one of those ones you did in your homework talking about laying cable and the cost to do it underwater or on land, which requires a different calculation. Don't do the same for both of them. This one requires dividing. Distance divided by speed will give you time, which is what we are trying to minimize quickly as possible, right? If it's a cost question, it's going to be minimizing the cost, and you have to multiply the cost, say, on land plus the cost underwater. A little different calculation, but the same setup in the diagram. So let's start with a picture. Picture's worth 1,000 words, and it'll get you on the go here. Okay, so we have a river, yes, we're off the river here, and we're 4 kilometers into the water here. So here's you swimming. Where's swimming? Kicking, something like that. And I am not an artist. And here's the finish line, which is 6 kilometers down the road. 6 kilometers, kms. And you can put your bicycle anywhere along here. Okay, so here's your bike. Has a seat and handlebars. It's very deluxe. And you're going to leave your bike there and you're going to swim to some point. So you're going to swim to some point along here, like that. You're going to get on the shore, jump on your bike, and you're going to get to the finish line. Yay, where you win. Because you know how to do the question. So what you should recognize immediately is that you have a right angle triangle here. The same setup every time you do one of these. And you want to make this part of your diagram, this part of your triangle, you want to label this x so that this distance could be 6 minus x. So if this was 4 kilometers, then this is going to be 2 kilometers. Okay, so, but we want to determine that x value. Once you've set up your right angle triangle, you know what this hypotenuse is, right? Well, if you don't, you need to go back to grade 9 or maybe grade 8. I'm not even sure when they teach Pythagorean theorem. Okay, so these are my distances. So now I need to know what the speed is. So what's his name here? Bill. Bill can only swim at 6 kilometers an hour. And he can cycle at 12 kilometers per hour. So the distance divided by the speed is going to give us time, and that's what we're trying to minimize. So remember, distance divided by speed gives you time. And again, if this was a laying cable question, underwater cost, land cost, then you would be multiplying this by the cost and multiplying this one by a cost. and adding them together to minimize. Okay, so just make sure you can do either of those. It's the only possibility here. Okay, so the time, and we're trying to minimize it, is going to be equal to, so let's just make this 16 plus x squared over 6. And to that, I'm going to add how fast Bill can ride a bike, which isn't very fast. I think Bill could do better. Now, before you start this, before you do the derivative, simplify. Okay, let me write that in nice pink for you. Simplify first, because you'll see that there are some things here that we really don't need to be working with. So I write this. This is 1/6. I'm going to write what's in the radical sign and raise it to the half power. This I'm going to break into two parts as 6 over 12, or 1 over 2, minus 1 over 12 times x. And I think you can see that this is going to make your life much easier. So if I do t prime now, I do a half times a 6th is a 12th. And I have 16 plus x squared, reduce the exponent by 1, and multiply by the derivative of the inside, which is 2x. The derivative of a half is 0, and the derivative of minus 1/12 x is simply minus 1/12. Now see how much easier that is rather than trying to take the derivative of it in this format? Make your life easy. You can do this. It's easy. Once you've done several of them, you'll have no problem. Okay, so this 2 can divide into the 12 6 times. Now I have to make sure that I'm keeping everything in the numerator. So I have minus 1 times x. I did this once and forgot the x, and it was a wreck. Okay, so I have x in the top here, and I have 6 times the square root of 16 plus x squared, minus 1 over 12. And now I'm going to say for critical values, set t prime equal to 0. So if I set this equal to 0 right here, I can move the 12th to the other side of the page. So I'm going to do that. 1 over 12 is equal to x over 6 square root 16 plus x squared. Sometimes it's just the little basic algebra that gets you mixed up. You know how to do the derivatives. So now if I was to solve for x, I would say x is this times this divided by that. So let's write that out. So I'm just going to really cross multiply here. So I'm going to get 6 square root 16 plus x squared is equal to 12x. I divide both by 6, makes this 2. I square, so divide by 6 and square both sides. And if you square both sides, you're going to get rid of that nasty little radical sign. And I get 2x squared is 4x squared. I subtract 1, 16 is 3x squared, and using my calculator, I'll get x is approximately equal to plus or minus 2.3, but x is greater than or equal to 0. Okay, so therefore, x is equal to 2.3. Now that wouldn't be a very nice answer if the teacher asked you where should, the question says where, let me find it, at what point on the shore should he aim to get from the starting point to the finish point? Okay, so you can either say, I think the easiest is probably to take 6 minus 2.3, 6 minus 2.3, which is 3.7. So therefore aim for 3.7 kilometers from the finish line. And there you go. There's your first question, and you get your 5 or 6 points or whatever for doing that correctly. You can do these. These are not hard. You've done a couple of them, you'll be off to the races. Okay, so let's move on to number 2. And then I'm going to give my voice a little break and maybe have a cup of tea and try to get me in shape to do some more for you. Okay, number 2. It says a rectangular picnic area of 8,000 meters squared is being constructed by the Parks Commission along the edge of a river. It will be fenced on 3 sides, but not along the river. Ornamental fencing costs $12 per meter, will be used on the side opposite the river, and chain link fence costing $3 a meter will be used on the other 2 sides. What are the dimensions of the fence which will cost the least to make? Okay, so back to our lovely diagrams, right? So we have, let's get some water here. We have water, and we're fencing in an 8,000 square meter. Oops, let me get this down here. 8,000 square meter picnic area. Okay, so here's my 8,000. Is it 8,000? Yeah, 8,000. 8,000 meters squared. And we have ornamental fencing here. Ornamental. And it's $12. And we have chain link on the other 2 sides. And it is $3. And we're trying to minimize what? What are we minimizing? That's what you need to ask yourself. It says, what are the dimensions of the fence? So we're minimizing this, which is the perimeter, right? Okay, so what's my perimeter? So I'm going to write minimize perimeter. So that's when you want to be taking the derivative of. You know that the area is, you can figure out area. So we have x, y, and x. So the perimeter is 2x's plus y. Okay, so this is just a perimeter. I haven't factored in the cost yet. But I do know that the area, which is x times y, has to be equal to 8,000. So 8,000 equals x times y. And this is what you call your equation of constraint. So it's an equation of constraint because I'm only making 8,000 square meters. So that means you're going to be able to use this to isolate one of the variables here, and you're going to be able to get rid of one of these. You want this only in terms of x or y. So I could say x is equal to 8,000 divided by y. And then I could plug that in here, right? But before I start that, I have to put in the cost. So I want the perimeter's cost. So this is great, but it's not going to help with my calculation because I need to put in this $3 and $12. So I have 3 times 2x, right? This is the cost for the chain link. And I have 12 times the ornamental, which is just 1y. Okay, so let's work with that, and then we're going to substitute this in. So I have 6x plus 12y, 6x plus 12y, and my x is going to be 8,000 over y. Plus 12y. And that's going to give me 48,000 over y plus 12y. Now let's take the derivative. So we'll say p prime equals, this is y to the negative 1, so negative 48,000 over y squared. Now you got all that? I meant negative y to the negative 2. Put the negative, or the y to the negative 2 down here. And the derivative of 12y is 12. Now I'm going to set p prime equal to 0 for critical values. And that's going to give me minus 12 or let's bring this one over here to make it positive. So 48,000 equals 12y squared. Did you catch that? I just brought this over and multiplied by y squared all in one sweep. Yes, I have a cold. And that's going to give me 4,000. So that means y is approximately equal to plus or minus. And now you're just going to take the square root of second square root of 4,000. And I get 63.25. And I always say plus or minus, and then I say y is greater than 0 because I can't have a negative length. So that means my y is going to be 63.25, and then you can find, let's just see what are the dimensions of the fence. Okay, so it's going to be 63.25 meters long. And so your perimeter, let's get what x is going to be. So x is going to be equal to 8,000 divided by 63.25. So let's do 8,000 divided by 126.48. Approximately equal to 126.48. Okay, so those are your x and y dimensions. Now, if your teacher has taught this after teaching you how to figure out if something is a max or minimum, you may also need to do a proof that you've found a minimum value. I'll put that in here just in case you haven't, or you have. So I would say P prime, and I've chosen 63.25. And I want to know if this is a minimum value. So if it's a minimum, then on this side, the slope would have to be negative, and on this side, it would have to be positive. So that means this must be negative and this positive for this to be a minimum. And if I chose, let's say 60 here and 60, let's say 64 or something on either side, and plug it into the derivative here, P prime. So if I did minus 48,000, let me see, divided by 60 to the power of 2, that gives me a negative 13.33. And if I added 12 to that, that would be negative. So it is negative. And if I go to the other side, I'm going to find that it's positive. I'm not going to waste your time. Okay, so that's the first two questions, and I promise I'll get on with the next few shortly. Bye for now.